Hello, in this video we're going to learn about histograms. Histograms are used to represent data over ranges of numbers. Histograms show a distribution of values within a data set. Each interval range must be equal in size and consistent. There are no gaps between the intervals, and there are no gaps between the bars of a histogram. So here is a picture of a histogram. Now you may be thinking that this is similar to a bar graph, and a bar graph is similar, but it is not the same. So the difference between a histogram and a bar graph is that you'll notice that we do not have any gaps between these bars. A bar graph does have gaps. So a bar graph, if I kind of draw one here for you, would be something like this, where you have gaps between the bars. Normally, if you notice down here, I have intervals for my x values along my x-axis. On a bar graph, these are typically words. Like if we were talking about like favorite colors, maybe this is red, and this is blue, and this is green. And so down here in a bar graph, these are typically words, and then the height is the frequency of the interval. So how many people said red was their favorite color, or blue, or green. In a histogram, all of the ranges, so 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99, they're all consistent, meaning they all have the same range. So they're from 50 to 59, that's 10 values. From 60 to 69 is 10 values. From 70 to 79 is 10 values. From 80 to 89 is 10 values, and from 90 to 99 is 10 values. It doesn't always have to be the number 10 when you're creating your intervals, but you always want them to be consistent. So whatever you pick for your first interval, let's say you choose to go from 50 to 52. 50, 51, 52, that's 3 numbers. So then your next one will have to go from 53 to 55. The next one after that would have to go from 56 to 58, and so on. So you just need to be consistent with your scale, and you need to have them go up by the same amount every time. You can't just jump from 50 to 59 and then 70 to 79. You would still need to have that 60 to 69 interval. The frequency is how many, like in this example, how many test scores occurred within the interval from 50 to 59. So in this case, we had 1 test score between 50 and 59, 4 test scores between 60 to 69, 8 test scores between 70 and 79, 10 test scores between 80 and 89, and 8 test scores between 90 and 99. This data in this frequency table is displayed in this histogram over here. And so we can see each of those intervals displayed. So we said from 50 to 59 there was 1. This one goes up to 4. This one goes up to 8, 10, and 8. So this is what a histogram looks like. Histograms can have different shapes. If all of the heights are the same, then we say that the histogram is uniform in shape. On this next one, we have 1 peak. So if there is 1 peak, we say that it is unimodal. On this next one, if we have 2 peaks, then we say that it is bimodal. And on this last one, we have 1, 2, 3 peaks. We say that it is multimodal. And we actually use multimodal for anything that's more than 2 peaks. Along with the shape of a histogram, it can also be skewed. So the most common is a normally distributed data set. And that is when we have a bell-shaped curve. This will happen when your mean is equal to the median. We can also have a negatively skewed histogram and a positively skewed histogram. Negatively skewed is also sometimes called skewed left, and that is because the tail is on the left side. One way that I remember if it's negatively skewed or skewed left is I draw a dinosaur. And my art skills are not the best, but you're going to get the idea here in a second. Alright, so here is my dinosaur. The dinosaur's tail is on the left. Because the tail is on the left, that means it is skewed left. The reason why we say this is negatively skewed is because the tail is where the negative numbers would be. So here the mean is being pulled towards the tail, making the mean less than the median. We can do the same exact thing for positively skewed data. Here we also can say that this is skewed right. And that's because if we draw our dinosaur, the tail is going to be on the right side. And so because the tail is on the right, we say that it is skewed right. And we call this positively skewed because the tail is where your positive numbers are. In cases like this, the mean is less than the median. So the mean is being pulled towards the tail.